Is it possible for us to manufacture the most dangerous object in the universe inside a lab? Yes, I'm talking about creating a black hole right here on Earth. Humanity has always played with forces it barely understood. Fire, nuclear energy, splitting the atom. But today on the border between France and Switzerland, 100 meters underground, sits a 27-kilometer machine that defies the limits of reality. The Large Hadron Collider. Its official goal is to unlock the secrets of the cosmos. But ever since its construction, a shadow of doubt has haunted the scientific community. Could we, in our attempt to understand the universe, trigger a planetary catastrophe? To understand if this is actually possible, we first need to bust a myth. In space, black holes are born when massive stars die and collapse under their own gravity, compressing a colossal amount of mass into an infinitely small point. But physics tells us that gravity isn't the only way to achieve this. There is a mathematical limit called the Schwarzschild radius. This principle states that any object, no matter its size, will become a black hole if you manage to crush its mass into a small enough space. If you compress the Earth to the size of a marble, it would become a black hole. If you compressed a person to the size of an atom, the result would be exactly the same. And that is precisely what CERN's particle accelerator does. We are going to look at the most terrifying dangers that have been raised over the years regarding this invention. But first, make sure to subscribe to the channel so you don't miss out on any mysteries, and leave a like. The Large Hadron Collider is a megastructure consisting of an underground ring. The tubes where the particles travel are under a near-total vacuum so that nothing obstructs their path. On top of that, the machine operates at a temperature of -271 degrees Celsius, around -456 degrees Fahrenheit. That's just a couple of degrees above absolute zero, making the particle accelerator the coldest place in the entire known universe. Among other things, it's used to fire proton beams in opposite directions, accelerating them to 99.99% the speed of light. When these beams collide, they pack a brutal amount of energy into a microscopic space. This energy is so dense that, according to some quantum physics theories, the fabric of space-time could tear, opening the door to the creation of artificial micro-black holes. This isn't just some internet conspiracy theory. Back in 2008, when the accelerator was about to turn on for the first time, the panic was real. A group of independent scientists went as far as filing lawsuits with the European Court of Human Rights to stop the experiment. They argued that the risk of creating an uncontrollable black hole wasn't zero. There was a real probability. They claimed CERN scientists were gambling with the fate of the entire planet. However, mainstream science breathed a sigh of relief thanks to the great scientist Stephen Hawking, though not for long, as we will see in a moment. Hawking proved that black holes aren't completely black. Instead, they emit a subtle form of radiation, dubbed Hawking radiation. Because of this phenomenon, black holes constantly lose mass, gradually fading away. And there is an infallible mathematical rule. The smaller a black hole is, the faster it evaporates. Under this premise, if the particle accelerator were to create a micro black hole, it would be thousands of times smaller than a proton. Its lifespan would be just a millionth of a fraction of a second. It would vanish in an invisible flash of pure energy before it even had the chance to absorb a single atom around it. It would be a tiny rip in space-time, seemingly harmless to us. But wait, this is where science gets unsettling. What if Stephen Hawking's theories were wrong? After all, Hawking radiation remains a mathematical theory that has never been directly observed, since no one has ever traveled to a real black hole. Theories can only take us so far. If Hawking was wrong, and an artificial micro-black hole turned out to be stable, the scenario changes completely. Since matter is mostly empty space, normal matter would seem hollow to it. Due to its subatomic size, smaller than an atom, the black hole would sink under the force of gravity, punching right through the lab floor and traveling straight toward the center of the Earth. For months or perhaps years, it would move back and forth through the planet, passing right through the core without us even noticing. At first, it would be so tiny that it would only devour a few protons a day, but over time, as it gained mass, its appetite would accelerate. It would start swallowing more and more matter, growing exponentially until the Earth's core began to collapse from the massive weight increase. It would silently devour the planet from the inside out, and we wouldn't even realize it. As if this scenario weren't disturbing enough, there is a real danger in particle accelerators that worries many physicists even more than black holes: strangeless or drops of strange matter. Inside protons, there are elementary particles called quarks. In the matter we know, quarks group together in a specific way. But in the ultra-high energy collisions inside the accelerator, extreme conditions could give rise to a quark soup grouped in a completely different way, a theoretical substance known as strange matter. The real danger of strangelets isn't just their existence, but their behavior. It is theorized that strange matter is the most perfect and stable state of matter in the universe. If a stable strangelet came into contact with the normal matter of our planet, it would trigger a catastrophic chain reaction. The atoms of our planet would reshape themselves to become just as perfect and stable as the strangelet. It would act like a cosmic virus, transforming every atom it touched into strange matter. In a matter of hours, the entire Earth would shrink and transform into a hyper-dense, dead, frozen mass the size of a football field, drifting aimlessly in the vacuum of space. Does this mean we should shut down particle accelerators immediately? The answer from astrophysics is, fundamentally, no. The universe has been running this exact same experiment for billions of years on an infinitely larger scale. Every second, Earth is bombarded by cosmic rays, high-energy particles traveling through space that slam into our atmosphere at speeds and energies thousands of times greater than anything humans could ever achieve at CERN. If these high-energy collisions could generate stable black holes or planet-destroying strange matter, the Earth and the Moon would have ceased to exist billions of years ago. Nature is our shield. The experiments we conduct underground are nothing more than a microscopic attempt to replicate what the cosmos already does naturally in deep space. Humans are just trying to strike a spark in the dark to understand how the engine of the universe works. Leave a comment below with your thoughts on the particle accelerator. After all, as long as we keep trying to understand the universe, the line separating scientific discovery from absolute danger will remain a thin and terrifying. Thanks for staying until the end. If you enjoyed the video, don't forget to subscribe so you don't miss any cosmic mysteries every week, and support the video with a like.